Hi everyone, this video is part 3 of Unit 1, and this video series is over the scientific foundations of psychology. This particular video will cover correlational research. So in some of the previous videos, we learned about conducting psychological research and different types of research methods. This particular video will cover the research method of correlational research. So to start with, have you ever heard any research findings like this? Studies show that people with mental illness are more likely to be smokers. Or studies show that ice cream sales increase the same rate as violent crimes increase. Maybe you've heard of things like this. They kind of sound like headlines. But these are correlational studies, and basically what they're telling us is that there's a relationship between two variables, but oftentimes people misinterpret what correlational research is telling us. So somebody might hear one of those things and they might think, wow, I should stop smoking if I want to improve my mental health, or I should stop selling ice cream in order to bring the crime rates down. And that would just be a misunderstanding of correlational research. So correlational research is just showing us that there is a relationship between two variables. So this type of research would collect data on two different variables like ice cream sales and violent crime rates. And then we would look to see if those two variables are related and to what extent. And so that's correlational research. So we can't really determine what is causing the relationship if we do find there is one. For example, if we were tracking student attendance and we were calculating the number of days that students were present in school, and we recorded those, and then we collected their scores on the AP psychology exam, we might find that students who had higher numbers of days present at school also had higher scores on their AP exam. But we don't necessarily know that the being present was the cause of that. We just might find out by looking at those numbers that they're related. So let's look at this example that I mentioned, that ice cream sales and violent crimes are related. So if we're looking at these on this graph, we can clearly see that there's a relationship. As one variable is rising, so is the other. But we can't necessarily say that one is causing the other. We just don't know that. So this research is really valuable. We can track all kinds of factors, and we can see if one is rising while the other is rising, or if one rises while the other falls. It's pretty helpful for us, but we just need to be really careful and remember that just because they're related and we see that relationship, they don't necessarily cause one another, and there could be a third variable at play. So for example, with this situation of ice cream sales and violent crimes, the third variable is summer and heat. And so we see that as we are moving into the summer months, people are buying more ice cream and violent sales are increasing, or violent crime rates are increasing, excuse me. Okay, and one more time, just to reinforce this point, we can track variables of all kinds, and we can just see if there's a relationship. So in this chart, you can see that we are looking at sunglasses sold and ice cream sales. And as you can see in this graph, that as ice cream sales increase, so does sunglasses sales. And what this means is that they're related and they share some kind of commonality. But that doesn't necessarily mean that people who are buying ice cream are now sensitive to the sun and need to buy sunglasses. What this is showing us is that they are rising at the same time, and they happen to be rising in the summer months when it's hot. Okay, next, when we are gathering correlational data, we start out collecting just the raw numbers. So you can see that in Table 1. So Table 1 is showing us the measurements or the collection of two variables for 10 different people. And it's showing us for those 10 people the number of months each person has owned an exercise machine and the number of hours they have spent exercising that past week. And so what we'll notice is when we place one variable, and I'll move my little picture here, when we're placing one variable on the x-axis and one variable on the y-axis, and then we record those data points, this becomes what's called a scatter plot. And so if you display these data pairs and you display them on that scatter plot that you can see, you'll move along. If you move along, you'll notice that we've plotted one data point here, that the fewer amount of months they're exercising more per week. And then as the months increase, we're noticing that the number of hours that they are exercising is decreasing. So this is a relationship, but we're noticing as we move left to right that the values on the axis, as we see on the vertical axis, the hours of exercise are growing smaller over time. And so what we're noticing is that the person is exercising, or it appears that they're exercising less the longer they're owning their machine. So in that scatter plot, what we've learned is this appears to be a relationship, but we see that it's moving downward. And when we see that this is moving downward, we're going to call this a negative correlation. And literally what this is showing us is that these two variables are working conversely. So as one variable increases, so the amount of months owning a machine, so if that one increases, then the other one seems to decrease. The number of hours they're exercising is fewer. So this is what we call a negative correlation. When one variable increases, the other decreases. And when we plot that, it from left to right kind of shows a downward slope. Okay, next, a positive correlation would be one where both variables are low at the same time and high at the same time. So in other words, what that would mean is when one variable increases, so does the other, or when one variable decreases, so does the other. So suppose instead of displaying hours of exercise on the vertical axis, you put the person's score on a test that measures your cardiovascular fitness. So in the pattern, these data points suggest on a line that slants from the lower left to the upper right, we see it's going in the opposite direction now. Now we see it's moving upward. So the longer the person's owned an exercise machine, the higher they're scoring on a cardiovascular fitness test. And so we would call this positive because as one variable increases, we can see as it goes up along one axis, it's also going up along the other axis. So this is a positive correlation. So there's a third possibility, and this is when one variable increases and the other one doesn't increase or decrease. And we're seeing that there's really no relationship at all. So if we see in this figure, on figure 3, we're noticing that if you're going to plot the months of exercise the machine is owned and the person's height, we notice that those things aren't related. So if we're plotting their height and then how long they've owned this machine, there's just no relationship between somebody's height and how long they've owned the machine. So we're going to say there's no relationship or no correlation. And this is what it would look like on a scatter plot. Okay, so we have lots of scatter plots here. You can see as you're moving, we have what we see here as a negative correlation. We're moving all the way to no correlation as what we've learned, then to a positive correlation. So when correlational data is plotted, sometimes the dots are more tightly packed, which makes this trend really easy to see. So you can see how tightly packed these are on the far left and far right. Whereas other times, your dots might be a little bit more spread apart. So you can see they're a little bit more spread apart. And it makes the trend a little bit less clear to see. This allows you to see how strongly correlated the two variables are. So the correlations that are the strongest and have the highest strength of a relationship are on the far right and the far left. We have almost a perfect positive and almost a perfect negative correlation on the far left and the far right. And so we can see that really clearly when we see this visual of the scatter plot. It's as if one variable is increasing or decreasing at almost a proportionate rate as the other one is increasing or decreasing. And so this is showing us that strength. And you notice here at the middle, we just have no correlation at all. Okay, so you can see here, it's now labeled with like a description. So you can see this is a really strong negative correlation, and we're getting to a really weak or almost none at all to a really strong positive correlation. Now we're going to add something to this. We're going to add a number value. So you can see on the diagram we have number values with the different scatter plots. These number values are quantitative measures where we can look at this number value and we can see just by looking at this number how strong a relationship is between two variables. And this is something called a correlation coefficient. So correlation coefficients are just like a quantitative measure that shows us a number value, and that number value shows us how strong the relationship is between the two variables. And so you can see here when there's no relationship, we have a 0 value. So AP Psychology students will not be asked to calculate a correlation coefficient, but you do need to understand what they represent. So you can see on this diagram that the farther away the coefficients get from 0, the stronger of a relationship it is. So this means that a coefficient of a positive 1 and a coefficient of a negative 1 both represent perfect correlations. They're very strong correlations. The relationship between the variables on those graphs is very strong, regardless if it's positive or negative. Those positive and negative signs just let us know if the relationship is positive or if the relationship is negative. But they are both positive 1 and negative 1 correlation coefficients are very strong relationships. And the closer you get to 0, the less correlated or the less likely it is that there's a relationship between those two variables. So you can see that here. This is a visual without those scatter plots that show a negative relationship, which is when one increases and the other decreases. And it also, you'll have that negative sign with it. The closer it gets to negative 1, the stronger the relationship is. And then we have that positive relationship, which means that the two variables are either increasing or decreasing at the same time. And the closer it gets to positive 1, the stronger that positive relationship is. On this diagram, you can see that the correlation coefficient is represented with the letter R. So R equals negative 1 or R equals negative 0.8. This is just letting you know this is the correlation coefficient. I think R equals is a really easy thing to remember because to me, R represents the relationship. So if R is negative 1, that's a really strong negative relationship. Or if R equals positive 1, that relationship is a very strong positive relationship. Okay, let's see if you can think about these examples and decide if you believe the variables negatively correlate or positively correlate. And remember, a positive correlation means that one variable is increasing and the other is increasing at the same time or decreasing at the same time. A negative relationship is where they're working conversely. So as one increases, the other decreases, or as, vice versa. Okay, so here are the examples. In example number 1, your first variable is media consumption. The second variable is happiness rating. And the finding was that the more children and youth used media, the less happy they were with their lives. So I want you to think if that's a positive correlation or a negative correlation. Example number 2 is variable number 1 is the length of infant nursing. And variable number 2 is the achievement they have later in life. And the finding was the longer children were breastfed, the greater their academic achievement was later in life. So the longer they were breastfed, the more months they were breastfed, the greater or increased their academic achievement was. So if you want to pause it and write down what you think, you can, and I'll tell you the answers. So in example number 1, that was a negative correlation. As youth used more media, they became less happy. And number 2, in that example, the longer children were breastfed, the greater their achievement, which is a positive correlation. Hopefully, you were able to pick that out. So correlation coefficients make it really apparent for us to know if there's a relationship between two things. And maybe even if we would miss the fact that there is a relationship, a correlation coefficient is that visible number that lets us know if things are related or not. And it also will help us see when there isn't a relationship. Sometimes we perceive that there's a relationship between variables when there actually isn't. For example, a very common illusory correlation is full moons and erratic behavior. And we might think that these two things are related when they actually aren't. And so this phenomenon is called an illusory correlation. It's the perception of an association that's not there. Okay, so I'm getting really close to the end of my video time length, and I hope this was really helpful in understanding correlational research.